So the next factor we're going to consider when taking a look at on-chain metrics and comparing blockchains is transaction speed. So transaction speed is the rate that data is transferred from one address to another on a blockchain network. The faster that a transaction is confirmed, the higher and better the transaction speed of that blockchain is. Now, transaction speed can depend on a number of factors. This can include, and is not limited to, block size, the size of the blocks added to the blockchain, block time, traffic, and transaction fees or network fees. First, let's talk about block size. So every blockchain network has an encoded limitation on how much data can be added at a single time, which is known as the block size. Each block on a blockchain is a collection of data to be entered into the database, thus adding another block to the chain of blocks. Different blockchains will only allow specific sizes of data entries per block entry. Now, for example, the Bitcoin network will only add block entries with a maximum of 1 megabyte per block. So just to give a visual idea, Bitcoin is based on a distributed ledger, a blockchain. In each one of these blocks is made up of records of transactions that crypto miners, Bitcoin miners, will assemble into these block formations. They'll bundle them together, they'll process them, and when they are completed and verified, they're added. That block of or bundle of transactions is added onto the blockchain. It'll be the next block added to this chain of information and transactions. Now, within that, different blockchains will offer different sizes in terms of blocks that can be added. So the Bitcoin blockchain will only accept blocks of the size of about 1 megabyte, right? Anything larger, it will reject, and the miners will not be able to add that block to the blockchain. They won't receive that block reward because it's an incompatible and invalid block. Different blockchains will offer different capabilities. They'll have different capabilities in terms of block sizes, right? Some of them will only accept 3 megabytes. Some of them will accept blocks the size of 3 megabytes and 2 megabytes, right? And this will vary from blockchain to blockchain. Now, the average block size of Bitcoin has not always been 1 megabyte. There's been a lot of changes, and it has been the cause of a lot of controversy and disagreements over the years that Bitcoin has been in existence, particularly with miners. Here we see, this is a chart of the average block size. This is from blockchain.com. This is from going all the way back from 2010. We see generally there's been a significant growth in the size of blocks that have been added to the Bitcoin blockchain, right? The earliest ones were very small, and this could be attributed to the general development of technology over the past decade or so. Generally we see this general increase, even surpassing 1 megabyte, sometimes nearing 1.5 megabytes, but we haven't seen anything lower than, let's say, about 0.6 of a megabyte in about 4 years, right? Anything lower than this would have been significant at this current time. Really, even in the past 2 years or so, in 2020, we haven't seen anything lower than maybe 0.75, 0.8 megabytes of data of the size of the block even being added to the blockchain. Here are just some more popular stats and relevant stats regarding the average block size, mainly pertaining to Bitcoin. This is from blockchain.com. They have a lot of charts and general charts regarding Bitcoin transaction fees, total transaction fees, the mempool size, transactions per day. So Bitcoin currently sees about 268,000 or about 269,000 transactions per day. We see general market price, the average block size, the mempool size. This is the size in bytes of transactions waiting to be confirmed, right? So there's a significant amount of transactions that are just waiting. They're waiting for confirmation. This is what the mempool size refers to. Some more details. So we see various block details, including blockchain size, the average block size, the average transactions per block, average payments per block, number of transactions. We also see confirmation times, which is the waiting time for how long it takes for a transaction to be confirmed. We see the median confirmation time and the average confirmation time. So these are all various statistics that are useful when we're trying to track exactly what's going on with Bitcoin, and we can start to compare these statistics of Bitcoin to other altcoins. Here's an example. This is actually from the Ethereum website. They talk about blocks. So why blocks? To ensure that all participants on the Ethereum network maintain synchronized states and agree on the precise history of transactions, we batch transactions into blocks. That means dozens or hundreds of transactions are committed, they're entered, they're agreed on, and they're all synchronized all at once, right? So all these transactions are bundled into the block, they're all approved, they're agreed upon, and then they're added all at the same time. And that's basically how the system works of adding information to a blockchain. It's not added transaction by transaction. They're actually bundled and grouped with maybe tens or if not hundreds of transactions at once, and then entered all at the same time. Now here are some reasoning behind the Ethereum Foundation and their decision on how Ethereum would handle block sizes and how it would change depending on overall demand. So blocks themselves are bounded in size. Each block has a target size of 15 million gas, but the size of blocks will increase or decrease in accordance with network demands. So depending on if the network is extremely congested or if the network is not so congested, the size of the blocks will increase or decrease, right? Up to the block limit of 30 million gas. So Ethereum has a network fee that is called gas, that essentially is a measurement of the computational work. How much processing power needs to be committed and used to process that transaction? And this could be a large figure depending on what's being transacted. Is it multiple transactions? Is it a large transaction? Are you trying to mint and move multiple NFTs at once? That's going to be considered a larger transaction, and the block size will vary depending on how much work needs to be done to verify and process all the transactions in it. Here are some comparisons between Bitcoin, Ethereum, and Dogecoin. So here we see in terms of blocks, the amount of blocks of data added. Currently, Ethereum is leading, at least in comparison between these two other coins, has 13 million blocks added to its blockchain. In terms of transactions, once again, Ethereum has an extreme amount. 1.2 billion transactions have been verified and added to the blockchain. We also see in terms of network nodes, there's no readied amount of nodes that we know that are processing and are analyzing and working on the Ethereum network, whereas we have set amounts for the Bitcoin and Dogecoin. And we also see the blockchain size. So in terms of size, what's interesting here is that the Bitcoin blockchain is a larger size in terms of gigabytes, 360.86 gigabytes, in comparison to the Ethereum blockchain, which is only 272.30 gigabytes. And even though the Ethereum has more blocks, arguably almost more than twice the amount of blocks. Is really only 697,000 blocks compared to Ethereum's 13 million. The Bitcoin blockchain is larger, suggesting that maybe the blocks have more data in them. They're larger blocks. There's a number of factors, and this is where we can start to compare the blockchains based on fundamental data, right? Fundamental hard data and on-chain metrics and statistics that will really say, oh, well, it's not just based on the financials of the coins or the market cap of the coins or the price movement of the coins. It's really based on the actual uses and what's actually going on in terms of the blockchain behind the coin itself. We can also see a block size historical chart. Generally, the Bitcoin block size has remained at these higher levels, right? And we have seen also growth in Ethereum and in Dogecoin as well. Dogecoin remaining relatively lower compared to Ethereum's growth and Bitcoin's growth over time.